Okay, this is section 3.6, question number 44, and what we have to do is find y prime using logarithmic differentiation. Alright, so what we want to start out by doing is just writing the original equation, and that's y equals x to the power cosine x. Again, first step is just writing the original equation. Alright, now next we want to take the ln of both sides, just so we can get this problem into a shape that we can differentiate it in. So we set ln of y equal to ln of x to the cosine x. Now we use log properties to bring this exponent down. So specifically the property we're using is ln of x to the y equals y times ln x. So when we use this property, we get ln y equals cosine x times ln x. So again, we just took cosine x, the exponent, and brought it down to the front using log properties. Alright, now we have it in a shape that we can actually derive. So the derivative of the left side is y prime over y. Now the derivative of ln x equals 1 over x. So over y it's 1 over y. But because it's implicit differentiation, we need to remember y prime. So 1 over y times y prime just turns out to be y prime over y. Now for this part here, we have a product rule. Now if we call this part A and this part B, what we have to do is A prime times B plus A times B prime. So derivative of cosine x is negative sine x. That needs to be multiplied times b, so ln x. We add them to a cosine x times b prime. And as we said here, the derivative of ln of x is 1 over x. Next, we simplify. So y prime over y equals cosine of x over x minus, because of this negative here, sine x times ln of x. Next, we want to isolate y prime. And to do that, we need to bring this y to the front here. So we'll just multiply both sides by y. Gives us y prime equals y times cosine x over x minus sine x times ln x. And we're almost done. We just have one more step, and that is to substitute x to the cosine x for y, because as we know from the first problem, or from the first step, y equals x cosine x. So where we have a y here, we just bring in x cosine x, giving us our final value of y prime equals x cosine x, x to the power of cosine x, multiplied by cosine x over x minus sine x times ln of x And there it is.